Alright, so here's a problem that we face on a daily basis. The average hippopotamus lives about 1.4 times 10 to the 9th seconds. Okay? The average lifespan of a ring-necked duck is about 7 times 10 to the 8th seconds. Which of the following express how many times longer a hippo lives than a ring-necked duck? Okay, so between the two of these, the one that lives the longest is the hippo. So 1.4 times 10 to the 9th power. He lives the longest. The one that lives the shortest is this duck. 7 times 10 to the 8th power. Alright, so they want to know how many times longer this hippo lives than this duck. So that means that the life of a duck times something is going to equal the life of a hippo. And that is what they're trying to get us to figure out. So I need to get that x by itself. Now in algebra, we do the inverse operation, which means the opposite operation. I want to get x by itself, so I want to get rid of this 7 times 10 to the 8th power. In order to do that, I have to say, well, what is that guy doing? What is he doing to x? He's either adding, subtracting, multiplying, or dividing. In this case, he's multiplying, because you remember, the life of a duck times something equals the life of a hippo. So I do the opposite of timesing it, and that is dividing it. So I'm going to divide it by 7 times 10 to the 8th power, cross it out. Because it's an equation, I have to do the same thing on this side, times 10 to the 8th power. So basically, x is going to equal whatever division problem this is. That looks nasty, but it's not really. Okay, so here's what you're going to do. We're going to take it one step at a time. The very first thing is I am going to divide 1.4 by 7. And I can do that very easily. You do not need a calculator. 1.4, don't forget to bring up your decimal, divided by 7. 7 will not go into 1 at all. Okay, 7 will go into 14 two times perfectly. So that means that this equals 0.2 times 10 to the 9th power over 10 to the 8th power. Alright, so now we've got to figure out what we're going to do about these guys right here. Now there's different teachers show different ways of doing it. This is the way that I show how to do it, just keep it simple. I say, let's get everybody upstairs. Let's get everyone to the numerator and make it easier. If I move this 10 to the 8th power upstairs, he is going to change his exponent to be opposite. Alright, so let me show you what that's going to look like. So this whole thing right here, whenever I move that guy upstairs, it's going to look like this. 10 to the 9th, but then when I move the guy upstairs, it's going to become 10 to the negative 8th. You see, his exponent changed to be opposite. Now, according to our exponent rules, if I'm multiplying numbers and they have the same base, I can combine my exponents. That means add or subtract them. So 0.2 stays the same, times 10, my base stays the same, 9 minus 8. I'm going to combine those. And what that's going to equal is 0.2 times 10 to the 1st power. So you might say, well, that doesn't look like an answer option. And you're right. It doesn't look like any of my answer options. And it's not even in correct scientific notation form. However, this is my answer. So I am going to have to put this in the standard form in order to see what it really equals. So I've got 0.2. This part right here tells me how I'm going to move my decimal. In this case, it says I'm going to move it to the right, because that's a positive. I'm going to move the decimal to the right one place. So I move it to the right just one place, and my answer is going to equal 2. So the correct answer is 2, right there.